Okay, let's go back now and work through this generalized Sturm-Liouville problem using a weight function. I've altered the interval here to be 0 to L instead of 0 to pi, just so you can see sort of how things will shake down in the general case. If we look at the Rayleigh quotient for this particular problem, so the Rayleigh quotient is going to be integral py prime quantity squared plus qy squared dx minus pyy prime, and this is all going to be divided by the integral y squared r dx now. So that follows from the same derivation that we did before, just including an r in there. Okay, and so in this particular example that we're looking at, p is the function e to the minus x, and q is going to be 0, and r is also e to the minus x. And so this becomes integral y prime squared e to the minus x dx over the integral of y squared e to the minus x dx. And so it should be clear from this that this is going to be strictly positive. As usual, it's non-negative because everything in sight is non-negative, and it's non-zero because the only way it could be 0 is if y prime were equal to 0, which would make y a constant, which by our boundary conditions would make y the 0 constant, and we would not get a non-trivial solution. Okay, so we solve this equation. So let's look at the characteristic polynomial. So I'll just use the variable s for this differential equation. So we have s squared minus s plus alpha. So the roots of this are going to be 1 plus or minus square root of 1 minus 4 lambda over 2, or 1/2 plus or minus I times, let's see, so if I move the 1/2 inside the square root, that's going to look like lambda minus 1/4. Okay, so the minus sign because I pulled out the I, right? Okay, so let's see, so then y is going to be e to the x over 2, a cosine x square root lambda minus 4 1/4 plus b sine x square root lambda minus 1/4. Okay, so here I just used Euler's formula, e to the alpha plus I beta x is e to the alpha x cosine beta x plus I sine beta x. Okay, so let's see, I can use my boundary conditions. So 0 is y of 0, which is e to the 0, so we have 1, and then a times cosine of 0 plus b times sine of 0, and so that tells me that a equals 0, and so then I know that y looks like e to the x over 2 times b times sine x. So now evaluating at our other boundary, we have 0 is y at L, so this is b e to the L over 2 sine L times the square root lambda minus 1/4. And from that one, we can see Well, the exponential is never going to give us a 0, so it has to be coming from a sine function. So we know that the L root lambda minus a fourth has to equal one of the zeros of sine, so that's n pi. And so that tells us then that our lambdas are going to look like n pi over L quantity squared plus 1/4. And then we have, and we're not including 0 here because that would zero out the sine function. So let's see. So and we have the corresponding eigen functions, which are e to the x over 2 sine of n pi. Okay, so let's just check orthogonality. So if I take yn, ym in the inner product here, in the R inner product, then what I get is, so we're looking at integral from 0 to L, and we've got e to the x over 2 sine n pi x over L times e to the x over 2 sine m pi x over L, and this is the R inner product, so I put my R in here. And then, of course, this is just one we've seen many times before. So these guys definitely form an orthogonal system with respect to this weighted inner product. So let me see. So from 0 to L, so that's going to be one of these ones that's there we go. So one final note. So earlier I told you that anything that looked like y double prime plus ax y prime plus bx y could be put into Sturm-Liouville form. Actually, so let me just emphasize the fact that it's needs to be self-adjoint. The thing to do is multiply by the integrating factor. E to the integral of a. So multiplying this one all the way across, so you have e to the integral of a times y double prime plus a e to the integral of a y prime plus e to the integral of a times y equals lambda e to the integral of a. And then using the mu notation, this is mu y prime prime plus mu b equals lambda mu b y. Oh, I forgot a b. That's what happened. Whoops. There we go. Lambda mu y.